Thank you for watching this help video. In this example, I'm going to explain how to factor this type of polynomial, identify the respective zeros, and the multiplicities of those zeros. So let's look at the example that we have here. And the technique for this is by grouping, factoring by grouping. So we're going to group the first two terms, negative 5x to the third power plus 20x to the second, and we're going to factor out and group the second two terms. Now, how are we going to get this? Well, you'll notice that in the first term, these two terms have a common factor of x to the second power. But you'll also notice that the coefficients also have a common factor. I can divide both of these things by the negative 5. So let's factor out the negative 5x to the second power. So dividing negative 5 out of the first term, that's going to give us x to the first power minus, because dividing negative 20 by negative 5 is negative 4, and factoring out the x squared is just going to give us negative 4. Now, because of this, our second factor, using again greatest common factor, by factoring out the greatest common factor, we have to end up with the exact same thing as this, okay? So I want to factor out a term. I'm going to put a blank space right there. So when I factor out that value, I'm also left with x minus 4. And again, this is just how this technique works. If this technique is going to work correctly, then factoring out the greatest common in the first term will give me a binomial, a linear binomial, which means that factoring out the greatest common factor here would have to equal to the exact same linear binomial. Now, if this doesn't work, then this technique again is not going to work, and I need to find another way to factor this. But if this technique by grouping works, then these two things should be the exact same thing. Now it's trying to figure out how to get this second term to have a linear factor of x minus 4 when I factor out the greatest common factor. Well, since I need the sign to stay the same, I just need to factor out this common value right here of 80. And again, that should always be the technique here. So to have this match up to this, I just factor out the greatest common factor in that second term. That leading coefficient, I'm going to factor out that leading coefficient in this second group here. So I'm going to factor out a positive 80. So I'm going to divide 80 out of both terms. So 80 divided by 80 obviously is 1, so we end up with 1x. And negative 320 divided by 80 does in fact equal to negative 4. So you see, I end up with that value. So let's see what we have. Now, as you'll notice, that since these two terms are in fact the same, I can factor this out, and I could take that out of both of these. So if I ignore that, factor it out, x minus 4, and ignore it, notice the only thing that's going to be left is going to be this term and that term there. So we have negative 5x squared plus 80. Now normally we should have again a situation where we can use the difference of squares and factor this by a difference of squares. But we have a problem. First of all, this doesn't have a perfect square root, neither does this one, and instead of subtracting, we're adding here. But I do notice that I have a negative 5 in the front of this term there. And I notice that 80 is a multiple of 5, meaning I can divide 80 by 5. So let's factor out that 5 from that parentheses. So let's factor out a negative 5. So if I take a negative 5 out of this second parentheses right here from both of these terms, I'm going to be left with x squared, and 80 divided by negative 5, that's a total of negative 16. And of course I still have this term here, so I'm just going to switch it and move this term back here. Now look at this. This is the cool part right here. Now look at this. Now I have a difference of squares. So I can break this up by the definition of difference of squares. That if I take the square root of 16, which is 4, I can break up this binomial into the following factors. So I have negative 5, and I'm going to write it in blue. I can break that apart that I've highlighted in blue as x plus 4 and x minus 4. And of course, I still have the x minus 4 at the end right there. Okay. Now, since these two are the same, I can write this as x minus 4 to the second power. So here is the completely factored form to this polynomial, which means that our zeros are going to be the following. X will equal to negative 4 and x will equal to positive 4. Now, what are their multiplicities? Well, x equals negative 4 a total of 1 time, and x equals positive 4 a total of 2 times. Because again, we have 2 factors of x minus 4, so we need to have x equal to positive 4 2 times, and since we only have one factor of x plus 4, I need x to equal to negative 4 1 time. So there you have your factor form, your zeros, and their respective multiplicities. I hope this video was helpful, and I appreciate you watching.